So the changes we've made are we have pitched up the end effectors so that they no longer sag down and they're flush against the payload. And we've also changed some of the admittance parameters, the mass, damping, and stiffness default parameters. And then right here, visualizing the force for each robot. Red is the force on Ross, which is the follower back here, and blue is the force for Monica, which is the leader. And now I will start the command velocity publisher after I unplug them. If you look closely, you can see the arm is slightly moving. That's the admittance controller adjusting the force, which is exactly what we want to happen. So it was roughly 2 meters. It looks like Ross ended up maybe 5 centimeters off.
Congratulations. I mean, the problem with it working is it looks so easy. I almost wanted to ask you, are you sure you didn't Velcro the box to the pads?
And that was just with some quick tuning. I'm sure if we were to model some of the dynamics, we might be able to get an even better response there.
All right, so now we have to make it look harder. I don't mean make it harder. What I mean to say is, you probably want to do some runs where you have intentionally slightly not optimal tuning. And, you know, I mean, we've spent many months looking at them trying to drive and then dropping it.
Yeah.
And now they don't drop it. And so we have to, this is what John was saying at the very beginning, right? We need to document very well that this is not easy, so that when it works, it's clear that, that you've achieved something. And it's what you were worried about the other day when we were talking. So congratulations. Now, I mean, obviously you need to do like 30 of these. And I think the next step is to get some guidance from John on how to make this, what he wants for next steps. And then you already started writing the paper. Yeah, I mean, I guess, yeah, all right. Congratulations. Is there anything else you wanted to show?
That's it for the demo today.
All right, perfect. Nice, short and sweet.
Mm-hmm. So as far as next steps and testing the robustness of the admittance controller, we've demonstrated that a constant velocity is pretty stable. I think a changing velocity, so sine wave velocity as they're moving, would be an interesting experiment, as well as changing acceleration. So we can see how robust our admittance controller is to those changes in dynamics.
Very good.